Good day, Chiefs. I hope you're all doing well and healthy. In this video, we will discuss topic 14, which is the last topic of section 11. Section 11 really involved everything that's in 3D shape, from solids like cones, cylinders, pyramids, prisms. Um, in this topic, which is topic number 14, we are going to discuss cross section and plane rotations. This should be one of the easiest topic that you will get exposed to in that section. Before we get started, let's go ahead and define what a cross section is. What is a cross section? Cross section is the shape we get when cutting straight through a solid with a plane. So imagine the soda can, for example. I think it's the So if I slice the soda can with a knife horizontally, what is the shape that I will get right on the top where I sliced? Something like a circle. That's exactly, so the cross section of the soda can is really a circle. In many cases, it's like the view in the mirror of something after cutting through it. You can also cut this vertically and you'll see something like this, which is a rectangle. We'll talk about all the cross sections in a minute. Cross sections are usually parallel to the base, like the figure below. But the cross section can be made in any direction. It can be made in a vertical, can be made horizontally, and it can be made diagonally. So we can cut through up and down, we can cut through right and left, we can cut through slanted. All right, before we keep going, let's go ahead and match each building represented on the table with all the geometric shape that it will be used to model it. Take a look at that building right here. It looks like a castle. So which of these that we can see in the castle? We see a cone, true. Do we see a cylinder? It's barely there, but it's right here. Do we see a pyramid? No, we don't see a pyramid. Do we see a rectangular prism? Yes, these are rectangular prism. Let's take a look at this. We see a cone. No, we see a half sphere. We see a prism. We see a prism. A rectangular, sorry, I touched a pyramid. I see a rectangular prism. We see a cylinder right there. Uh, Here's a cylinder. Last one, we only see a pyramid. All right, next question. Let's take a look at the examples. What is the shape that's projected on the gray plane? Draw. So actually, before I get started here, I'm gonna stop presenting. And I'm gonna go back to the website I opened, and I will show you what each thing is, but now I'm gonna present something else. So present Chrome. So I want to present this. So these are the cross sections of different shapes that we are learning. So take a look at this. This is a cylinder. You probably can see. We can go. You see the plane that's in blue is really what we're slicing. So it's the knife that goes through the can. Okay. Even if you tilt it, it's still a circle, but it can become a little oval shape kind of thing. Okay. You can turn it Okay, so all of these are just ways that shows that no matter what, your cross section of the cylinder is always a circle, but the cross section of the horizontal figure, okay, of the horizontal figure. So the horizontal plane cuts through it horizontally will give us a circle. But what happened? Okay, hold on. I think I had. I'm sorry, I did lose the link somehow. So I am going to find the link again. Okay, here it is again. Let me present it to you. And this link will be included in with that video. It will be included with the video. Okay, so that's a cross section of a cone. You can see the horizontal figure. It's giving a circular base. Okay, again, whether you go up or down, it's still circle because it's parallel to the base. Even if you go up a little, the circle only gets smaller, but it's still a circle. That's the horizontal. Let's see the vertical. See how the vertical looks like? Again, you see the vertical? I'm going to show you when it's rotated. It's a triangle. And as we rotate the triangle in the axis, we get a cone. So, and cylinder. I didn't show the vertical of cylinder. You see the vertical of cylinder is a uh, oh, I'm not sure what just happened. Click on it again. Go back. Come back here. All right, triangle. Okay, so we can see if I did it vertically, it becomes a rectangle, and we can also see the rotation of a rectangle makes a cylinder. The rotation of a rectangle makes a cylinder, and horizontally it was a circle. Vertically is a rectangle. What else I want to show here? There's multiple ones, sections of cones. Let's do the sphere. Sphere is kind of straightforward. No matter where you cut through the sphere, you're getting a circular shape. So you see, I go vertically, still a circle. I go horizontally, is a circle. I go up, down, it's still circle. It just gets smaller or bigger based on that. That's the section of a sphere. I will do the pyramid section, not that one. Triangle or pyramid, probably can see that horizontally, whether we go up, down, it is a triangle. Vertically is also a triangle. Here we go. Triangle. Rotation does not make it a. You can play around with these tools a lot. I just wanted to show you how they all look like. I know we have a rectangular prism, and I want to show that. So horizontally in a rectangle prism, it's a rectangle because it's parallel to the base. But vertically is also a rectangle because it's parallel to the face. When you rotate the rectangle, you'll get that. All right. I'm going to pause here for all of this. I will include this link. It's on GeoGebra. Um, you can work with it. You can play around with it. It's very useful. And I do wanted to tell you that you should study cross sections very, very carefully because they are on your next test. Okay, so I'm going to stop presenting. I'm going to go back to my notes. And I don't know what happened to my notes. It's disappearing. I think they closed by accident. Alright. I know this video is now longer than usual, but it's okay. And okay. All right, now we can continue with the R notes. And again, that link will be included with this video. I will post it with the video. It's a very nice animation that helps all different kinds. All right, moving on to that example where we left off. It says, what is the shape of the projected in a gray dot? Now, I've shown all of this. This shape right here is a triangular pyramid. And a triangular pyramid, when you cut down horizontally, it really gives you a triangle. Remember, horizontally is parallel to the base. Vertically is parallel to the face. So whatever the face of the shape is will be the cross section vertically. Whatever the base, the shape of the base is, will be the cross section horizontally. So this is a triangle. Try this. So this is a triangular pyramid again, but it is going up and down. This is a vertical. The gray plane is vertical, so it goes up and down. And again, it is parallel to the face. What's the shape of the face? In here, the face is a triangle. So that's also a triangle. Let's take a look at the third one. The third one is a cylinder, and we can see the gray goes horizontally. What's the shape of the base? The shape of the base here is a circle. Okay, so before we move on, I'm going to summarize here. Okay, so horizontal, cross section is parallel to the base, and then vertical cross section is parallel to the face or the side of the solid. Okay, all right. Let's take a look at the next example. I highly doubt that you try this on your own and see if you can get it. If not, come back here. I'm assuming that everyone tried. In the table below, describe the shape resulting from vertical angle horizontal cross section in each solid. This is a triangular prism. The first one is a triangular prism. The base is a triangle, and the sides or the faces are all rectangle. So if I cut vertically, it has to be parallel to the face. So what's the face here? Face is a rectangle. Good. Angled means it's going in an angle. So it's like that. The best way to draw this is to actually I'll trace it with like orange. This is angled. Triangle. Horizontally. Now horizontally will be the same way. It's parallel to the base. The base is a triangle, so it's also triangle. The difference between angles and horizontal. Well, horizontal is the same size as the base, but the angle can get smaller or bigger based on how wide the angle is. That's it. Vertical. This shape is a cone. Again, the base of the cone is a circle. So horizontal would be a circle. Again, it just gets smaller as we go up. That's all. Angled this way right there. Again, it just, if you angle your circle, it becomes oval or ellipse. The ellipse is an oval shape, but it's the geometric figure. Vertical. means up and down. It goes this way. You can check that on the website, and it will be a triangle. Because the face of a cone is a triangle. So again, this matches the face, this matches the base. Matches the face, the horizontal match the base. Okay, this is really the key. All right, next problem is, it says match the cross sections of each solid on the left as it corresponds on the shape of the right. Try this on your own, okay, and come back and see if you got the right answer. Two circles, two rings. The horizontal for this will give us a rectangle. I know, sounds weird, but yes, it is. Here will give you a triangle, and here will give you a circle. I did the sphere, I did the triangle or prism before, but you can tell, here it is. I don't know if you can see it, but that's how it looks like. In this one, it's hard to see, but here it is, rectangle. This one, it will be one circle in and one circle out. That's why it's two circles. The sphere is always a circle, and any way you do it is always a circle. Describe the shape of the cross-section of the following object. Right circular cone, cut plane through the vertex, perpendicular to the base. Here's the cone. Okay, where's my vertex? Vertex is right there. So I'm cutting through the vertex. I'm going from up all the way perpendicular to the base. I'm going this way. So if I'm going up and down, that means it's a vertical plane. What's the vertical cross section of a cone? Again, the face, the vertical matches the face. So what's the face of a cone? Triangle. Then therefore, this would be a triangle. Next one, square pyramid cut by a vertical plane that is parallel to the edge of the base but doesn't go through the vertex. So square pyramid normally looks like this. So the plane vertical, so it goes up and down, but it doesn't go through the vertex, so it doesn't go from here. It has to be somehow slanted, so it's like this. So this can be, you probably can see it right there, and then here, here, here. What's that shape I just traced? Trapezoid. Describe the radius of a circular cross-section created by a plane through a center of a sphere with a radius c. Again, here's the sphere. Here's the radius. And if I want to find out the cross-section of a sphere, anywhere you cut the sphere, you get a circle. So the cross-section is a circle. That's all the cross-section. Okay, you can remember them because they're easily to memorize. Just check the website, okay, or refer to the notes. All right, if we rotate the following polygon around the given line, what is solid should we produce? Now remember, I showed you the rotation on also the same GeoGebra website. So if I rotate a semicircle, I should get a rotation. I will get a sphere. Triangle, I'll get a cone. Rectangular, I'll get not a rectangle prism, I'll get a cylinder. Why is this not a rectangle prism? Because the rotational move itself is a circular move. Okay, that's why it's a cone here, not a pyramid, and it's a sphere here. Okay, so a semicircle will give us a sphere. A right triangle will give us a cone. A rectangle will give us a cylinder. Please remember these. All right. Here's some old mathematical concept. Pretty easy, but it does kind of what is it? It works with everything that we have learned so far. I'm only gonna do 5. I don't have to do the last one. All right, what is the surface area of the geometric solid that's produced by the triangle? So the solid that's produced by the triangle. So if I rotated this triangle, what do I get as a solid? We get a cone, right? So I need to find a surface area of a cone. Let's write the equation of that. The surface area of the cone is pi RL plus pi r squared. The lateral plus the area of the base. So in here, we only have two not known. We don't know what R is. We don't know what L is. Well, the slanted height is this. This is the slanted height. This is L. R is this distance right there from N to O. How do I find R given L? Well, I can find R using trigonometry. So this is H. This is 45, so that's adjacent. Remember the sine, cosine, tan? Which one is it? This is adjacent in H. That's A and H. So that's a cosine. So cosine 45 equal adjacent, the R, divided by the hypotenuse, 5 square root of 2. R is on the top, we multiply. So it's 5 times 2 square root times 45 cosine equal 5. So R equal to 5. That's it. Let's plug it in. 3.14 times R is 5 times L, 5 square root of 2, plus 3.14 times 5 squared. That's it. Let's do some math. Should be 189.5 and units squared. Now, the last problem here I can walk you through, but feel free to try it, which is the volume. It says, what is the volume of the geometric solid produced by the triangle below when it's rotated 360 degrees about axis RU? So again, when you rotate a triangle, we get a cone. So you're going to find, here it is. You are going to find the volume of the cone. So the volume of the cone is 1/3 pi r squared h. We need to know R, we need to know H. Remember, 18 is not H in this case because 18 is a slanted height. We have to find this distance. That's our H. U to N, that's our R. We use trigonometry, and again, you can start finding H by using the cosine, then finding R by using sine. This is our hypotenuse. Okay, this is our H to height, this is H to hypotenuse. I just try to put a lower on. That's it. Once you find R and H, you can plug it in to find the volume. I'm sorry, it's been such a long day for me today, and when I decided to record this video, I had to choose the best time where my baby sleeps. So at this time, this video has ended. You please watch the video towards the end. You will get a some questions that comes out of the notes. I will include the link with this video, okay? If you have any questions or need help with anything, I can probably give you some more resources. If you would like, just let me know, okay? Until we talk next, stay well and healthy. Bye now.